Everyone, seems like we got a couple hundred people already joining us. So we'll just wait for a few more minutes to let everyone to trickle in, and we'll get started in about 3 or 4 minutes.
Nice to see a lot of different countries represented and watching the places go by.
It seems like we're getting a lot of questions about the recording. This session will be recorded, and we'll be posting it to YouTube shortly after the event.
You think we should get started or a little longer? 3 minutes after, maybe 5
Yeah, I
minutes
think
after?
the rate of people joining has slowed down a little bit, so it might be good to just get rolling.
All right, I'll get started then. All right, welcome everyone. We're excited to have all of you attend and uh, learn about Abacus.AI and operationalizing machine learning models using the Abacus platform. I'm Siddharth Naidu. I'm a VP of ML and Research here at Abacus.AI. I'll let Austin introduce himself.
Hello, I'm Austin Zellman, machine learning platform lead here at Abacus.
All right. So this is sort of the agenda for today. We're going to focus on one specific aspect of the platform and machine learning in how it can help machine learning in production and getting custom models into production. But I'm going to start with an overview of Abacus.AI. The platform has many components, and we want to give you an overview of like sort of the overall scope of what we support. And then we'll spend a little time motivating the need for allowing custom models and the challenges with operationalizing custom models that Abacus addresses. And then we'll take a look at a sample notebook as an example of like what a custom model might look like. And then Austin will walk through how that notebook can be made into a production machine learning model that is monitored, refreshed, managed by Abacus, so that all of the sort of tedious and heavy lifting related to like running a model in production can be handled by the platform. We'll go into some of the advanced usages around this, especially related to like debugging and understanding what your model is doing when hosted by the platform. And then we'll spend a little bit time zooming out and talking about how that fits into the broader ecosystem of like all of the things you can do in the Abacus platform to add machine learning to your operations. So that's the rough agenda. Like I said, we'll start with like Abacus, an overview of the Abacus.AI platform. So the goal of Abacus.AI is to enable companies of all sizes and all sort of data science capabilities to operationalize machine learning models in their businesses. The machine learning is, increasingly being used to address problems across a variety of business challenges, and being able to operationalize that model is an ongoing challenge and something that many companies struggle with, even if they have like good data sources, promising models, promising opportunities to tackle with machine learning. So Abacus has assembled a whole set of modules and a whole set of features that make this process easier to manage, easier to run, so that you can get from your data to a model working in production with fairly little effort. And the amount that the platform can support is it supports all the way from like just plugging in your data sources, pointing one of the templated use cases that's available in the platform to your data sources, and automatically building a model, evaluating it, monitoring it, and deploying it in production for use, either via online sort of predictions or batch offline predictions. So the platform itself supports the end-to-end usage around machine learning models. The model building Abacus has like fairly extensive model building capabilities that cover like a number of use cases like forecasting, recommendations, and even just general predictive modeling that we'll give a little bit more detail on later on. But within it are a variety of components to support each of these use cases that can be used across these use cases. A common machine learning problem is adjusting your data or manipulating your data so that it's transformed into a shape that's appropriate for models. So there's a lot of data transformation capabilities. There's automated model search. There's the ability to like set up refresh schedules and monitoring so that you can monitor models. And the one that we're going to focus on today is the ability to bring custom model and code into the system. So the overall sort of like flow for using machine learning in general, and how the Abacus platform is set up to enable this machine learning platform is, you have a use case in mind. It might be something like recommendations. You have data sets available that have your behavior of your users or behavior of your systems captured historically. You combine those, feed them through the Abacus platform. It searches over possible models and then produces a model that you can start to use in your business, right? So one of the goals while building the platform is to allow companies to use the platform at a level that's appropriate for their usage and their expertise and resources and so on, right? So we can use the platform at a very high level and let the platform manage everything from like data transformation to more model generation and model hosting to more nuanced usage or more advanced usage where you can uh, mo modify or customize custom parts of this process, right? You might want to customize the data transformation step. You might want to customize even how the model is built or what kind of model is built. And for companies that have the resources to do that or have a business use case for doing that, the platform supports allowing the customization, but still getting all of the operationalization uh, aspects of the platform. And then finally, you can go all the way down to like just being almost like a research platform where you're running custom code with notebooks and containers, which is kind of the lowest level infrastructure offering. So with that, we're going to focus today's sort of talk, today's workshop on using Abacus.AI to do custom data transformations and custom model construction, training custom models on the platform using the platform's infrastructure and tooling. To motivate that, I'm going to start by going to a notebook that sort of corresponds to, how we might tackle a brand new problem when we are trying to solve a business problem. So I'm going to present like a example problem. It's of course a little bit hypothetical because it's designed to like kind of cover what we need in the workshop, but it is realistic in that like it works with a data set that is actually taken from like one of the Kaggle competitions, and it is the kind of workflow that many data scientists will be familiar with. We'll walk through this workflow in a notebook that you might have hosted on a Jupyter running on your laptop or using some Jupyter hosting platform. In this particular case, we're using Google's Colab to like do some data science development, and then we'll go through what is involved in essentially doing the same process on the Abacus platform. So let me just take a quick pause to make sure there's some of these questions that we'll come back to towards the end. Definitely address them. One question I will sort of quickly answer here is this workshop focused only on the Abacus platform? Well, the data science part is not particularly specific to Abacus. The model building code uses the standard Python data science ecosystem and libraries and so on. But the operationalization part and hosting of this model is specific to hosting on the Abacus platform. So I don't think there are any other questions. So without sort of further thing, I think I'll jump in to the notebook, and then we can come back to some of these questions as we go along. So the notebook that I have here, I've got it filled out so that you can like pretty much run it without any changes. But we've also provided a link to an sort of like blank templated form of this notebook, so that you can write your own custom code or even work with a different data set or try something different, your own variation of what we're covering in the workshop. If you want to just like follow along with the notebook that's on that link, feel free to just follow along with the notebook as it is filled in. So in this notebook, we're going to start by getting some libraries installed because we're working in Google's Colab and our data is hosted in S3. We're going to just install the libraries to access S3. Google Colab has a couple of other libraries already installed. So, this is the only thing that we'll need to add for now. Taking a little longer than usual, but it should be done pretty soon. Yeah, there we go. Okay. Hopefully there's an error there, but hopefully that should not cause an issue. Okay. So the data set that we're going to work with is a concrete strength data set. It's a somewhat well-known public data set that has been used by, sort of like many data science sort of exercises or workshops and so on. It's a data set that describes some properties of concrete and a measured strength of the concrete, right? So these properties are describing what the how the concrete is mixed, or the recipe for the concrete, various sort of values for cement, slag, and other ingredients that go into concrete, a property about the age of the concrete related to like how long back it's been set, and then a measurement taken that measures the strength of the concrete according to like however engineers measure those kind of things. So it's a fairly standard data set. It happens to have mostly like numerical or numerical values. Other data sets may have numerical values. They may have some categorical or string type or discrete values. It doesn't matter too much, for example, like what exactly the data set is, but we're going to kind of like walk through what kinds of things you might want to do with this data set, right? So one of the things that's pretty common is, depending on what we're trying to do, we don't work with the input data as is when building a model. We have to perform some kind of transformation. Some of the transformations are simple things like filling in missing values, or filling in or removing rows that are bad rows or somehow unusable rows. But other transformations can be more complicated and can involve like doing some processing over the entire data set, and may essentially impact like the kind of model you're trying to build, right? Like you might need a transformation that the kind of model you're trying to construct requires. So in this particular example, I have a transformation that takes this data set that we just loaded and transforms it into two groups. One group where there's this fly ash, where where the concrete has no fly ash, and another group where the concrete has some non-zero amount of fly ash. Fly ash is one of the ingredients in the concrete. The reasons for this are not, again, it's just a hypothetical example, but this is the kind of operation that is fairly common, right? Like when you're building some model, you realize that maybe it's not good to like build a model over the whole data as is, but to build like a model that is sensitive to some feature in a special way. And in this particular case, we're choosing fly ash, and we're choosing to separate our data and transform it in a way such that rows with fly ash are defined, are sort of transformed differently from rows without fly ash. So you can see out here, like I separated into two parts with fly ash and then concatenated back after subtracting out like the mean of the various columns other than age to the two pieces, right? So I compute like the mean values of I take out the means of like all of the columns in two separate groups depending on their fly ash content, and I leave age unchanged. So I can run this transform, and I get a new data set. My new data set no longer has fly ash in it because I treated it specially, and I don't want to use it as a feature of like my model. But it has all the other features transformed in a way such that their means, are going to be their means have been removed according to whether or not they have fly ash. So at this point, I have a data set that is transformed. So I'm going to train a model, and I'm going to train a somewhat non-standard model, because I'm going to train a model that consists of a mix of a linear model and a gradient boosted tree model applied to different portions of the data set. For the gradient boosted model, I'm going to use the popular CatBoost library, which has a lot of bells and whistles around building gradient boosted trees. It's a fairly effective algorithm for a number of like predictive modeling problems. And now here is what my custom training function looks like. So I am going to train a model with this data set that I transformed above, and I'm going to train it on the strength column, right? I want to predict the strength of the concrete, and so I simply drop that as from the input training features. I use it as the target for the model, but I'm going to train two different models. I'm going to train one model that is applicable to concrete that is less than 10 years old, and a different model for concrete that is older than 10 years old. So I create a little marker feature to indicate which rows correspond to young concrete and which rows correspond to old concrete. And then I load a couple of modules related to shaping the data so that I can build a linear model. The most important one being because I'm building a linear model and the data is like highly nonlinear, I quantile transform all of the data before feeding it to the linear model. For the CatBoost model, I don't need to do any transformation because tree models don't really care about, they don't really care about the different other than the monotonic nature of the feature, they don't care about like exactly like how the feature is linear or non-linear. So I don't need it for that part. So what I do then is I take all the recent rows from my data. So I call the recent model is the linear model, and I just fit the linear model using only the recent rows, both for X and of course the target. And that gives me one portion of my model. And then I have another model that is based on CatBoost. I set up the training data for the CatBoost model, then train the CatBoost model on it. I have the resulting CatBoost model as an object that's usable, and I bundle that all up, right? So I bundle up the columns that I used for my model, the quantile transformer that's needed by the recent model, and then the CatBoost model, and that's my final model that I've trained. So this is the model that at the end of this training process, I must looks like a little carried away with the, yeah, there we go. So I have two models, a CatBoost model and this thing, and all of them combined out here. If any of you are following along, the change I made was I changed the depth from 20 to 10 so that the CatBoost model would not fail on the training. There's a maximum limit that the CatBoost model can take for tree depth. Once I have the two models, I have an R squared of 0.84 for the linear model, R squared of 0.87 for the CatBoost model. And now I have to be able to use this model on data. And since it's a more complicated model than a single simple either a linear model or CatBoost model, I have to make the predict function aware of like the age specific behavior of these models, right? So my predict function is a little bit more complicated than like a simple prediction function. It takes as input the data that needs to be predicted. It then creates the inputs for the models, but based on whether the age of the input is less than 10 or greater than 10, like I applied the same filter I applied at training time, it chooses to predict using the recent model versus choosing to predict using the older model. And so this prediction function goes along with the training function, because in my training function, I made this decision to like separate out the behavior around new and old concrete. And so the prediction function respects that same behavior. And then I have a little test here to just go ahead and test how my model is doing on some new rows and some old rows, right? So I just select out, 5 new rows, 5 old rows, and just run my prediction function on it, and I get some kind of result that that I get out here. So again, like one thing I will emphasize, I mean, as many of you, like I assume, are data scientists. There's a tendency to focus on like the details of the models, and we can talk about the R squared, whether this even makes sense to split it this way, whether there are other ways we can split it, and there's certainly different, better, cleverer things we can do for predicting the strength. But that's not the focus of this notebook. The focus of the notebook is how to show you how that you have a fairly custom data transform and a fairly custom model training and prediction sort of logic, and how you could make this custom model work in a operationalized way without having all of this logic just tied up and locked away within a notebook or within some scripts or within some very custom sort of way of running and applying this. If you wanted to like deploy this in a way that was like reliably usable in a production pipeline, that is what we want to focus on. So it's the combination of somewhat customized and complex logic around training and prediction, combined with a platform that can make it easy to operationalize this customized logic. So this is what we want to focus on. So just what in the context of what it means to like productionizing this model, you want to store the different versions of the model, right? You're going to be training this model multiple times, training this model on new data sets. You're going to be training this model as you tweak your model training function, and you want to be able to track that history, keep track of the various models you've built. You want to be able to host this model in a scalable manner. Right now, I'm having it run on a notebook and just running it with testing, but I might need to host this model in a way that it can support 10 TPS, 50 TPS, 100 TPS, maybe 100 TPS in the morning and 10 TPS at night. So there's scaling and auto scaling and all those things that you need to worry about for a model. You want to be able to continue to monitor your model. So yes, we've trained the model. It looked good during our testing training thing. We got a particular R squared, but is it working like that on the concrete it's seeing in production as new predictions come in? What was the new predictions? What were we predicting? And in cases where evaluation data is available, we can go back and I just want to address like one thing, because this is a question come up. Yeah, so the depth equals 10 has to change in cell number. This is I don't know how you get this, cell number 7. So in this train function, there's an argument to say cat boost regressor, and there's a parameter that says depth equals. That should be equals depth equals 10 or depth equals 5. It doesn't matter, just not more than 16. But depth equals 10 works fine. Okay, and then the supporting the model and monitoring the model's performance over time is another big feature. And then even monitoring the model's inputs, like you might see that the model is predicting, like its predictions are degrading over time, but you also want to understand whether it's degrading because like the nature of the inputs itself has changed over time. Maybe some field that was not null is now suddenly null all of the time. Maybe some data that was in the range of 0 to 100 is suddenly becoming in the range of 100 to 200, and the model has never been trained on that data. So all of that monitoring also exists. So to get all of this implemented around this notebook is not trivial. And what we're going to switch to now is Austin is going to show how to make that simple using the Abacus platform.
Thank you, Siddhartha. So in order to get started with the Abacus.AI platform, we've encoded a special link in the bottom of this notebook. So if you are just catching up right now, please navigate to the bit.ly link, which Kim will repost. It's the bit.ly Python model. Thank you, Kim. This time with HTTPS. So once you get to that notebook, scroll all the way down to the custom Python model, and I will share my screen with you all here so we can join in the same spot. So now I have my custom Python model. So we have this link here to sign up for an Abacus.AI account. This will give you a free trial that's not available anywhere else. For the Abacus.AI platform, this will allow you to use all of the features inside of Abacus. The only limitation is that your deployments will automatically spin down after a certain number of hours. And in order to get an unlimited time on those deployments, you would then have to upgrade. But for the purposes of this demo, you will be able to use all of the features inside of Abacus, including all of our connectors and and being able to build your custom Python models in the platform. And then, yeah, so click on this link. We'll bring you to a special URL with a sign up token that'll allow you to create your account. I've already created my account, but you can use your Google sign in, GitHub login, or create using username and password. And we'll give everyone just a couple of minutes to set up the account. It should be pretty quick. And while people are working on that, again, I got some questions again about the link. This is at the very bottom of the first notebook that we're working through. So it's the custom Python model notebook. We have a link at the very bottom that says sign up. So we can also, yes, copy that link directly into the chat. I will do that now and post it for you all in the chat. While we're going through here, so we also had some questions about hosting. Where does Abacus host its processes? So the part of the benefit of the Abacus.AI platform is that we are cloud agnostic. So we run in any cloud, any region of your choice. So that it allows you to run in AWS, GCP, Azure. We sit very close to your services, so that it reduces latency, keeps you inside of the same cloud or same region. And that's part of the benefit of working with Abacus. So we will, in the course of this example, use data from S3, but you can pull data, regardless of the cloud you're in, you can pull data from a bunch of different services, from all the blob storage, as well as services like Snowflake or Salesforce. So hopefully everyone's started being able to trickle in and create your account. So in order to get started, we're essentially just going to create an API key, which will allow us to then integrate with the Abacus platform. During the second notebook, we're going to take the model that we just built and learn how to be able to train and deploy this model, and then track the data coming in for predictions inside of the Abacus.AI platform. So once you've created your account, you should see a welcome screen like you see on my screen. And the very bottom right-hand side, you should see a prompt to want to use your API, create an API key. Otherwise, we've also provided a hot link directly to the API key dashboard inside of the notebook. So I'm going to click on the create API key. So this will give me my dashboard for my API key, so I can create a new demo notebook, give it a little tag so I know what I use this API key for. I'll then get a brand new API key, which is specific for my user. And then what we're going to do is click on the very bottom link, and we'll also paste this in the chat as well, if you're just catching up and joining along, which will bring us to the end-to-end platform demo notebook. There's also some questions too about hosting. You do need a Google account in order to use notebooks inside of Google Colab. If you don't have one, you can always download the notebook and run it locally. We can host it on GitHub as well. So that you should just be able to hit file and save this notebook. That will allow you to run your notebook locally. And we also have hot links, the sign up, as well as the API key dashboard links at the top of this notebook. So we've got the link. Thank you, Kim. So we're going to go ahead and get started with this notebook. So we're going to install a new dependency. So previously we had installed the S3FS pip library, which would allow us to, in Colab, talk to S3. But we no longer need that because we're going to be using Abacus.AI for our connections. So I'm going to go ahead and get rolling on this notebook, installing the Abacus.AI library. In the second box, we're going to insert the API key that we had copied from the dashboard. And again, that's once you've created your account, specifically using our sign up key or sign up link, you can then go to your API key dashboard. If you've forgotten it, you can click back here, copy it, and then go back into the notebook and paste it into the cell, and make sure to paste it before hitting run. If you accidentally hit run, it's stored the empty API key. So just paste and then hit run again, and that will set the variable for the API key. All right, and checking on the, so some people just joining. Just feel free to pop along or join along. We've posted some links, and we'll keep posting links in the chat of how to catch up to this notebook. And just follow the prerequisites to sign up for an Abacus.AI account, as well as grabbing an API key. And yes, I will definitely allow you to catch up. So yeah, again, just create the Abacus.AI account using this sign up link in the prerequisites, and then go to the API key dashboard, and then paste that API key that you get from the API key dashboard to set your variable. All right. Excellent. So once you're there, and don't feel too bad if you've fallen a little bit behind. You should be able to quickly catch up. I'm going to talk through every single step along the way. So if you are a little bit behind, you should be able to paste the API key and catch up. And so I'll talk through exactly what we're going to do. So after we've set the API key, we'll then create import the Abacus.AI library and initialize it with the API key that we just inserted in the previous step. And then the first thing to do inside of the Abacus platform is to create a new project. So inside of the Abacus platform, we have three top-level concepts. We have the project, which is describing what MLOps or specific deep learning use case we're trying to solve. We then have data sets, which are pointers to, or either data uploads or pointers to external services for where Abacus can fetch the data from. And then finally, we have a third concept called a feature group, which can be considered views or transformations on top of your data from your external service or your upload. So what we're going to do is first create a new project using the use case Python model. And this will create a new project in the Abacus.AI platform for specifically hosting and training Python models. And so everything that you're doing in here inside of this notebook is just showing you how you can automate a lot of these steps. All of this can be done inside of Abacus.AI. So when we go in and create a project, this will create a new project on our dashboard. Likewise, you can also just go in the dashboard, create a new project, select select any of the use cases and create your Python model through that. But for now, we're going to continue through the notebook. So once we've created the project for the Python model, we're then going to grab our concrete strength data set, which we had displayed in the previous notebook. So what this section of code here is going to do is check to see first, have we already imported this data set? And if not, then we're going to go ahead and create this data set from a file connector. So we have three different types of connectors in the Abacus platform. We have file connectors, which connects to blob storage. So this is S3, GCP storage, Azure storage. We also have database connectors, which connects to anything under the sun using ODBC or using services like Snowflake or Salesforce. And so we'll go ahead and hit play here, and this will create our new data set from file connector. So this is going to give it a unique table name inside of our system called concrete strength. And then it'll point it to a location of the S3 location that we had in the previous step. Since this is a public bucket, or we can publicly access this file, there's no need to set up the authentication. But if this was a private file, then all we need to do is go into the dashboard. And we have a whole suite of connectors. So if you go back to the API key dashboard, click on connected services, you can add file connectors, click on S3 and go through the verification process of giving Abacus.AI access to your blob storage bucket. So let's see. More questions. Doesn't look like anything for me to address at the moment. So what Abacus right now is doing, so we've now gone and grabbed that data, and we're actually importing it and running some inspection jobs on top of that data. This will allow us to view the metrics on the data and understand the breakdown of the data that we're importing. We'll then be able to take this data set and then upload our Python transformation that we had seen in the previous step. So this is going to just take a moment, but while that's going on, a couple more questions coming in. There will be a recording later. We'll be posting it to YouTube and following up with a link and a follow-up email. Let's see. So going along here, I'll just, while this is continuing to inspect, I'll talk about what the next step is going to be. Once that data set is finished inspecting, we'll then be able to describe the feature group that references this data set. So every time we create a data set, a feature group is automatically created, which is doing a very simple select star on top of that data. So you can do one of two things when you're creating feature groups. You can create a feature group which performs a SQL operation. So you can do any form of SQL, select, filtering, renames, group bys on top of your data, or you can run a Python function on top of your data. So you can just receive the data as a pandas data frame, and then perform additional operations on top of that to do the transformations. So we're still taking a little bit here, but I'll talk through essentially what this is doing. So once you've created your transformation on top of the data, you can then materialize that view. So that's going to apply the transformations and save that data to disk. This will then allow you to load up that, or then we can then export that data back to our notebook locally so we can interface it with it. But you don't need to do that in order to preview the data. Inside of the platform, we allow you to preview your data frame even without materialization, so you can preview what the transforms will look like. But this would allow you to get the entire materialization available for you to play around using a pandas DF locally in your notebook. All right. So let's we'll continue waiting for that to go. So let's see. So we'll go ahead and hit play. Seems there'll be a little bit of a backlog on the pipeline. So I'll continue talking through this. We'll just queue up this materialization and then continue through. So now we need to register our Python function. So we have our initial data frame of the concrete data set, which we'll then be able to run locally. But we also want to be able to register into Abacus our transformation function that we had defined in our first notebook. So I have this function here, the transform concrete. So this is the same one that was in our initial notebook. And I'll just define that locally inside of this notebook, which it'll take in a data frame, and then it will apply the transformations and then return a new data frame, which will have the transformed values. Inside of Abacus, if you wanted to include additional data frames, so let's say you wanted to join or filter based on another data frame, you can add as many data frames as you want to the input. The only restriction here is that you need, or that you return a single data frame as the output, and that will be your final data frame from this transformation function. And so once we've loaded all that data back into our notebook, we can, of course, test our transformation locally, make sure we're happy with the function. And then once we're good on that iteration, we can then register the function with Abacus. So when we actually want to register the Python function, we can call using the API client a create feature group from function. This is going to use, or it's going to take in the new table name, which will be how we refer to this in future feature groups. So in this case, we'll call this the concrete by fly ash. We'll give it the source code. You can pass in a string or even a function reference, which is what I'm going to do in this case. So this will just take a run inspect on the source code function or for this function, and then upload it into Abacus. Then all I need to do is tell it what is the function name, and then what inputs do I want to send to this feature group. So in this case, I will be passing just the concrete strength feature group into this Python function. So I'll go ahead and register this function, and it appears that we have caught up in terms of the notebook. So we did have some questions on the wait for inspection. As I had mentioned, what that's doing is importing data from S3, and then it's running an inspect job to get metrics on top of that data, as well as determining what and given that this is a CSV, we're going to also determine like what is the data type for each of the columns. This one was taking a little bit longer than anticipated, so it took about 4 minutes. Usually this is under 30 seconds. Seems like we've got a little bit of backlog with 600 some people running it all at the same time. But we've now caught up. We've materialized the data and was able to load it back as pandas, so you can see, hey, this is all my data. I'll jump over to the product and show you, this is all set up inside of the project here. So we have our data set, our concrete strength. You can see this is where it is imported from. You can always create a new data set version, which will go in and re-import that data from S3. And we did run that inspection. So you can see that we've determined the data type for each of these columns. You can view the raw data of this data set, as well as do some data exploration. So this was the results of the inspect job. You can see the distribution of the data inside of your data set. Likewise, if we go over to the feature groups tab inside of the product, you'll see the initial feature group, which was the just select star from our data set. You can, of course, edit this to do additional transformations, but instead what we did was just define a new Python feature group on top of that initial feature group. So you'll see the function that we just uploaded, which is the transform concrete, and it has a source feature group of the concrete strength. So we're going to pass a concrete strength into this transform concrete, the transform function, and return this. So in order to run this, all we need to do is materialize the transformation on top of the data. So that will materialize the view and run our function on top of the input data. So we've now registered the function. So all we need to do is call create version, and then it will kick off a job to materialize. So that will run our function inside of Abacus.AI. So let's see. Have some questions just to repeat what we're doing. So essentially what we're doing right now is we've created and defined this feature group, which is a view on top, or a set of transformations to apply on top of our input data. So you can stack as many of these on top of each other as you want. So you can do a SQL transformation followed by a Python transformation, a join with other feature groups, and then do additional queries on top of that. And then once you've defined all this giant set of transformations, then all you need to do is call create version. Inside of the product, we have buttons for this to materialize. So this is just materialize latest version. This will take everything up until this point in the terms of the transformation and materialize it and save it to disk so we can use it for our model training. And likewise, you can also by having it saved to disk, you can then load it back into a notebook. So you can call load as pandas, which will then download all of that data back into the notebook. any materialized version can also be exported. So once you've exported your data, or once you've materialized your transformations, you can use Abacus AI just to export your data directly back to S3. So if I had an S3 bucket set up, I could call export, I could give it the location to send my data to, and that would make it available for me. What we've done now is we've created this Python function on top of our concrete data set, which will apply the transformations. We're then going to go and redefine our model training steps. So we need to define our training function as well as our predict function. So what we're going to do is, again, install cat boost. This is just to allow us to run the code here inside of our notebook. This is not required if you're just uploading the model code, as Abacus will install the required dependencies for your Python function. So to talk through what's going to happen here, we're going to define our training function, which will take in any number of inputs, feature groups. In this case, we're just going to give it a single training data set of the concrete data that we've transformed in the previous step. And so this should be exactly the same. The only change here is that we did, in fact, have the correct depth here in the model. So this is, we seem to have a typo in the first notebook where we had 20. This is just going to be set to depth 2. So we'll define this function, which will train our linear regression model and apply cat boost. And then finally, we'll return we'll return our model. So what is going to happen is that inside of Abacus, when we call the train function, we'll tell it what feature groups we want as input to our train function. And then everything returned from the train function will then be available to our predict function. So we'll also train locally. So what we're going to do in the next few steps is we're going to define what our train and predict function look like locally. We'll then upload these functions to Abacus, and then we'll tell Abacus to go train, and then we'll deploy that model so we can make predictions, and we'll compare our locally trained model with our Abacus trained model and show that it's exactly the same. And then we'll show, continue to show you how we can then debug and these models, and then show you also how we can run some batch predictions, train these on a schedule, and then also be able to view the prediction metrics over time. So once we've trained locally, so we see the locally trained function, we have our local model, we'll then define our predict function. So our predict function will take in the results, which will be the tuple that we've returned here. And then also the query. So the predict function has a pretty defined signature, which will just be, this object will just be a pickled return result of the previous function of the train. And then the query will be any data that is passed via the predict API. So this will be any dictionary or query that you want to send in will then run our function on that query. So we'll define this predict function, and we'll show some local representations of what we expect to see as a result. So for each of these, we'll iterate through a few of these rows from the training data set. We'll call predict with our locally trained model. We'll pass in the dictionary or the row as a dict, and then compare it to the actual value. So you can see that our model is now predicting versus what the actual value was inside of our training data set. Not a great model, but it was a model that we were able to train in a matter of seconds. And of course, we can of course do better if we increase the training time, as well as perhaps use some deep learning inside of the Abacus platform. So let's go ahead and register this model. So we do the same thing as we did for the create feature group, where we'll create a model from functions. So in this case, we're going to give it the project reference. So in the beginning of the notebook, we created a project for this purpose. So we'll pass in our project, We'll give it the train function reference. So we'll call inspect and get the function name and signature from that. And secondly, we'll get the predict function and pass that in directly as well. And then finally, we just need to tell it what lists of feature groups do we want as inputs for the train function. So we'll click play on that. That will upload all of this into Abacus and kick off a training job by passing in this feature group to the train function. So this next step will just sit and wait for the model to actually train. And then it will get the logs from training. So what it's going to do, this wait for training will just continue to pull Abacus, waiting for the training job. It'll then get the model version results, and we'll call get training logs. And we can say, hey, I want both standard out as well as standard error. And then finally, all in one block here, we're going to create a new deployment. So a deployment is just going to be a container for being able to call predict or be able to call this API. So this model will be deployed and available, and it will then invoke the predict function with every query we pass to it. So this has been a lot of information. We'll quick jump back to the Abacus platform and show you exactly what just happened. So we have our project of the demo Python model. We have our input feature group, the concrete by fly ash. So this was the Python transformations on top of our imported data from S3. That was then materialized and then passed to our demo Python model, which we call demo Python model. So this is now training. If we take a look at the model code, this is a concatenation of both the train function as well as the predict function that we defined in the notebook. So this was all concatenated and put together in a single file. And we've defined that the training function name is train and predict function name is predict. So if you had a lot of auxiliary functions here, all that we need is just a hook to say, hey, what functions are we supposed to call for each of these steps? And so train will be called during the training portion. And then when we deploy this, we will call the predict function with the output of the train function, as well as the query that is passed when we call the deployment API. And so this is now going and training on the Abacus.AI servers. And so once that is done, we'll then, our code will then deploy that. So likewise, if you were inside of the UI, a new button would appear once this is done training to deploy. And you can create a new deployment, and we'll continue on from there. So let me take a quick step and see if there are any questions for me to answer. Some questions are, can we use the Abacus.AI account in the future? Yes. So there is not a time limit currently on the free trial. So feel free to use it and experiment with it. Let's see. Another question is, can you access the UI? Yes. So in the once you've created the account and have a API key, all of these, or as you go through the notebook, you will be able to, if you refresh the page, you should see your projects and feature groups and data sets that you've created. You can also do all of these steps through the UI. So we are showing how to very quickly change or take your current notebooks. So if you had a notebook or went through a step-by-step in GitHub for how to create a model on a specific set of data, you would be able to quickly take that notebook and just call a few of these APIs where it will automatically upload the function and invoke these values. But if you had a larger set of functions that you wanted to supply, you can always upload the entirety of your Python files inside of the UI, and then let Abacus handle the training.
Austin,
yes.
So there are a lot of questions around like the overall capabilities of the platform outside of just like custom Python models and how it compares to other platforms like AWS, SageMaker, and so on. I just wanted to because there are a whole bunch of questions related to this. We will cover more of that towards like the end as we zoom out and like look at the product from a higher level view. Just because I'm answering questions as you go, but I just wanted to call that out.
Yes. Yeah. So I definitely see a lot of these questions now about what AutoML capabilities and functions does Abacus have. So as we had mentioned in the beginning, Abacus is not just the MLOps. So we provide a lot of useful tools for you. If you have functions that you've already trained, if you have a model that you want to deploy, we allow you to even deploy a Dockerized or a containerized version of your model that we'll supply the hosting for. We'll also show at the very end too about how to actually create a feature store, which you can then quickly look up information on your feature groups in a real-time fashion. But Abacus also supplies a lot of tools for deep learning in AutoML that are specific to recommendations, forecasting, classification, and regression. So even this data set in particular, Abacus can perform a deep learning training using our own algorithms, which will perform much better than the CatBoost model version that we're seeing right now. So yeah, the purpose of this webinar in particular is to show you how you can use these tools to take your existing code, use Abacus for actually just taking that model and deploying it to production and having a lot of useful tools available to you. But we can also do complete end-to-end using that, and we'll show you how you can set that up towards the end of the webinar here. And we're again hitting a little bit of a backlog in terms of the training jobs with everyone hitting this, but this should be done in just a couple of minutes. While that's going on, I can actually show you how you could do this using the product. As mentioned, we have a lot of different use cases available to you. In this case, if we wanted to apply the same thing to using deep learning, we can just use the predictive modeling use case. And then from here, I can give this create a concrete project. And then I will then skip and go directly to uploading. So you can then create a data set. In this case, I'm going to attach an existing data set I've already uploaded. And I'll give it my concrete strength. And then by attaching this, it will then, oh, I seem to hit the button twice. All that I need to do is tell Abacus what I'm trying to target. So let's say I take my CS MPA, which is what we're trying to actually predict. And then all I need to do is tell it, hey, this is the value that I'm trying to predict. And then that's all I need to do for setting up the project. And then I can hit train models. And this will then create a new model for me using deep learning and AutoML, which will then be available again for me to deploy and predict in real time. So while that's going on, I think we're still waiting for that Python model to finish training. So let's see if I can answer any additional questions. Can we use some pre-trained models? So Abacus does have some pre-trained models depending on the use case. In this case, we don't have anything pre-trained because this is on the concrete data that we've uploaded ourselves. So this is not something that Abacus necessarily has a pre-trained concrete strength model ready to go, but we can, let's see. Any limits on the trial account? The limit should be on just the deployments. So how long you can create or have your deployment running for. So once we've trained our model, we'll then be able to deploy it and serve up that model in real time. And so that's the only limitation, is that after a few hours, the model or the deployment will automatically spin down and go offline. You can still spin it back up. So there's no limit on the number of times you can spin it back up. It just won't be continually on.
Austin, couple more limits.
Yes.
So one thing, we do have limits on like the training data size in the free trial accounts. For enterprise accounts, we can scale to like much larger data sizes. And there was also a question about PySpark. It kind of falls in the same bucket for like large data and for distributed training. We support it, but that requires like an enterprise account. But you should be able to train like 100 megabyte data sets without a problem with the free tier. But there is a limit that is lower for free tier than full enterprise usage.
Thank you. All right. So let's see. We will, let's see, we're still hitting some backups on this. We'll go ahead and talk through the last few items here while this continues to train and the deployments are spun up. What we're going to do is then compare our locally trained model inside of the notebook, and then predict, and then call client.predict on our deployments. And we should see exactly the same things back to back, where the locally trained model is equivalent because it's the exact same model that we trained. And then what we're going to do is take this deployment, which is referring to a specific version of our model, and then define a batch prediction for to be able to run on a schedule. So let's say that in our hypothetical situation, we have a whole bunch of concrete mixes that we're testing. And rather than making a prediction every time we make a new mix, let's say that we just have a few thousand rows that we want to predict all at once. So in this case, what we're going to do is actually import, in this case, the exact same data set, but it could be a brand new data set instead of the one we use for training. We'll then create a batch prediction. All that's required for the batch prediction is to give it the deployment ID that we want to use. And inside of Abacus, our deployments have two concepts. One is a offline deployment, which is only used for batch predictions, or a online plus offline, which is both used for real-time predictions as well as batch predictions. So when you create the batch predictions, we'll give it a table name for the output, and then we'll set a dataset remap. So what this is doing is it's actually taking our training dataset and swapping it with our new prediction dataset that we're just uploading here. The benefit of this is that we're applying the same set of transformations. So any sort of SQL feature groups or our Python function in particular will be applied on top of the prediction data set in the same way that that was done during training. And so this is just setting that remap. And then finally, we can kick off a batch prediction run. So once we call batch prediction.start, we'll create the run. It'll then wait for the predictions. And then finally, it will output all of this data to a feature group, which will then be available to load up as pandas. So we'll download all the batch prediction results and show it here. And then the last item inside of this, so now that we've set this in a notebook, our goal was to be able to then run this on a schedule. So how can we do that? So in the UI, as well as the API, you can set up refresh functions. So what this is defining is using a cron syntax, we can create a refresh policy on each of our objects. So on our initial concrete data set, we can set a refresh policy. We'll then also refresh our prediction data set. We'll then set a refresh policy on our model, which will automatically retrain our model on a schedule. And then finally, our batch prediction, we can automatically run our batch predictions also on the same schedule. So this just ties it all together to be able to run this automatically over time. So there's a couple of people saying that there is they're hitting timeouts on the wait for deployment. So some people did make it through the actual training. Seems like there's just a little bit of a backlog in terms of the creating deployment, as we have a limited pool for our free trial. So if you did hit that case of waiting for the deployment, feel free to just copy this, wait for deployment, and rerun that. So not entering a new deployment and rerunning. That will allow you to just continue waiting. There's also an additional like timeout field here. So if you wanted to wait additionally long, you can set the timeout to be much longer. But that otherwise, inside of the UI, we can continue monitoring this and see when this finally catches up. Yeah, let's see. So from here, fortunately, can't view the logs at this point because the model is still not finished training. Because the next part of this notebook, I'd like to be able to show one, being able to make the predictions in real time, and then be able to show off our model predictions as well. And then from there, being able to help use the product to show you how you can better debug your Python models. But with this, I think it might be a good idea to hop over to Siddhartha's notebook where he shows off a little bit of how you can do some advanced debugging with your model training while we wait for these models to catch up in terms of training. And then we'll be able to continue through inside of the product and show you a bit more of what's going on here. And you're muted, Siddhartha.
Sorry. Yeah. Yeah. Let's do that. I can start sharing, Austin. So yeah, continue and this one. Yeah, for one of the things that will come up, you guys saw it even with the initial notebook when I was developing locally. Errors do happen, problems do happen while training models. So it's important to be able to see like what those issues are and be able to like inspect, make corrections, or even generally just get informational data from like the model training process that you might want to look at and review. Now, of course, the usual workflow is like most of the debugging. The one of the things we aim to do with this workflow is that you can do like a lot of the model development locally, so you can like address like sort of the main issues or any like sort of simple errors while developing the model in your local environment, which is much more convenient and interactive and easy to work with and so on. But then when you're running the model on an ongoing basis, maybe there's something about the Abacus environment that's important, or you're hitting memory or some other limits in the Abacus environment. So, those logs are important. But I wanted to just call out like most development, since you can develop the function locally, you can get most of the feedback locally before you even push the function into Abacus. But once the function is in Abacus and you run some of these operations, so for example, this is again the same notebook, but going through some of like the potential like error use cases, right? So we start out with the concrete data set and we define, we look at the feature group, we look at what's in the data, and then we define our custom transformation. And in our custom transformation, we have some code to log some information about the transformation and potentially some checks, some data quality checks, right? So this is why it's important to have logging in Abacus, because all of these operations are intended to be pipelined and run in sort of like a continuous fashion, so that they can be updated with new data, can be refreshed as the training data evolves over time. So you might hit an error in new data that you didn't hit when you were originally developing and testing your function on like your initial data set. So in this particular case, like I have an example of like putting in a test to make sure that the means are within some reasonable range, because that was what was available when training the data, and that might not be the case, right? So when you ask Abacus to run the code and then look for the materialized data, it'll say that the feature group materialization failed because it couldn't run the Python function that you supplied for whatever reason. So then you can go look at like what happened to that feature group. So when you go and say get the feature group version that you try to materialize, and say get the materialization logs, and you want to look at both the standard out and standard error, you can see what's happening out here. The standard out, from the logging statement that was added to standard out, there is the means that was logged, that were computed for each of the columns, that was going to be subtracted before feeding it to the model. And in this case, the means had the means ranged from a couple hundred to down to like 4. And for, because we had the condition saying that all means must be greater than 10, the condition got triggered by this, by the super plasticizer column that has a mean of 4, and we were just not expecting it. And so, we can flag the error. So you can look at this error in your notebook, but of course it's also like convenient to like look at logs in the product itself. So that's, when it comes back to uh, goes back to Austin, he can show you some of that in the product too. But this demonstrates like what all information is captured and how you can like inspect what's happening in your code. Similarly, for the training function, we can put in some conditions. We can ensure that like the model is converging as expected. I essentially like this out here is a test for like the model's R squared, and you want to confirm that the model R squared fits below a certain value. Plus, you want to log some information from the training. So in this case, it logs some information, I think, about the quantile transformer, but it gets this like crazy, unrealistic R squared of like negative many 100,000, like 150,000, which makes no sense. So you see this error, and the model training fails, saying that I couldn't get a model with like the sufficient accuracy that was put in. So the reason that failed is because when I was computing the R squared, I was doing the R squared computation in that hypothetical example without applying the quantile transform first. But if I apply the quantile transform and then like log the R squared and confirm that the R squared is greater than 0.5 at least, I'll see that everything works as expected. I get still the logs for what was working. I log the R squared that I actually saw in the model training of 0.81, and then everything succeeds. The same is true in your prediction functions. Any code running in Abacus's environment is subject to like unexpected conditions or throwing errors. So you can get errors when you're predicting. In this particular case, we were asking for prediction requests without passing in the age column. So I'm running the same example code that Austin showed in his notebook. I'm running it now in an incorrect way by sort of dropping the age column, which is expected by the predict function that you've encoded. So you get an error and you get a stack trace from the Python code that's all captured and returned to you in the prediction response. So you can monitor for these errors when using the prediction function and understand if something is going wrong in your code. If something goes wrong in Abacus's code, there'll be a product level or API level error code that'll explain what was going wrong from Abacus's platform side. But if the error occurs within user code, it will capture the stack trace information and return it so that you can look at it. The one last thing I wanted to mention is for the purposes of like this notebook and for the and often it's convenient to like be able to like just push functions from your notebook itself as you're developing, so that you're not like you're not limited by so you're not limited by having to like save files somewhere else or source code or like make additional artifacts for like using the API. You can just use the function as defined as a Python function in the notebook itself, and the source code and all is extracted from the Python object itself to push into the API. But that begins to become a limitation as you get to more complicated training scripts or functions that are like dependent on each other and calling each other in complicated ways, or you're using a library that you've written and you want that library to be included in your function. So when you get into these more complex use cases, you're not limited to like just what is in a notebook. You can actually include like the whole like script file as what is going into what is being registered with the function. So in this particular case, I have the same sample code all saved in a GitHub repo. This is the GitHub repo that I created for this workshop, and in that I have this script that has all of these functions that we've been covering in this notebook as just a regular Python script. It's a Python fullscript.py. It has all the functions defined together in one place, and now I can set up my functions instead of passing in the actual function defined in the notebook. I pass it a pointer to, not pointer, but I actually pass it the contents of the script, which is the full script that I had saved in GitHub. I pull those contents and say that's the function source code, and it can define more than one function. It doesn't have to be limited to defining a single function. And I tell it what is the function name to use for the training, what is the function name to use for prediction, so they can use common functions. Each of them can also call into other common functions and have complex dependencies like that, or shared code and all of that. So you're just like passing you're passing sort of the function by name, as opposed to like function by reference kind of thing. And then you still need to specify what inputs the function will take. So that will, the platform will load that Python code, inspect it, find the functions that you've referred to by name, and then pass in the inputs that you specified as inputs when invoking the function. After all of that is done, the rest of the code flows exactly the same way. So this is the same result that you got by passing in the function low, and then you can in this case this was the case that had the function test to say that it was the test to say that like there's an R squared check and all of that. So the previous version of the code had like sort of just like a runtime error if you got a very low R squared, and then a warning if the mod error got like a R squared that was lower than 0.85. So in this case, the function still succeeds and there's no exception, but you get a notice saying that the function got a lower R squared than expected. So that sort of like covers the more like the somewhat more advanced usages and some of the debugging features available for working with the platform and working with code hosted in the platform. Hopefully that covers the thing. So Austin, I don't know if you want to switch back, or if you want to like maybe go into some of the platform, like if you want me to like sort of go into some of the platform and usages, because there are a lot of questions about templates. So it might be worth spending a little bit of time covering the use cases in a little bit more detail.
Yeah, so I can take some time here to go over a bit of our feature store, as well as looking at the logs inside of the product. So there is still that backlog going on for all the training jobs right now, but I think some people are starting to get through part of that. But I'll go ahead and check out some of the other features inside of the product, because I did have one that I had trained yesterday. So let's go ahead and I will share my screen again with everybody. All right. So I'll jump back over to what this should have been. So if we go ahead and open up our demo Python model. So once this has been deployed, we should then be able to make the predictions on top of our model. So we can, if we open up our deployment, we can open the prediction API, which will allow us to take this exact code and we can actually make predictions. So if I can copy this code and go back to the notebook, which would then allow me to make predictions. Otherwise, if I fed in example test data, so let's say rather than waiting for this to train, I can interrupt that, grab an example test row. So if I then just say took one of this, let me just go ahead and print the inputs here. So let's see, I can print the r.toDicts to get an example entry. And we'll not call that because that is not yet deployed. So let me then grab this. And actually, this will not be valid JSON syntax, so this will not paste exactly correctly. So if I were to quickly change that to valid JSON, we should then be able to see and make an example call here on this model. So let me repaste this. So now with valid JSON with the query data, so passing in all the cement readings, and we'll remove the CSMPA, which is what we're trying to predict. So we'll hit run here. And assuming that this is our Python function is working, yeah, we'll get a CSMPA back. So now that the deployment's warmed up, this will go much faster. So now this is, and so we can change our readings and try out different values in here and get different CSMPAs as a result. Now, we can make those real-time predictions, but what we promised was being able to see our prediction log and do some model monitoring. So now that we have this deployment up, we can receive a certain number of requests per second. But let's say I wanted to also debug and to know roughly like, hey, what was my query log time? So we see that initial startup. The first ping on the Python deployments are always a little bit long. After that, we're down to 4 milliseconds on the query. We then have the example result. And so if I wanted to say, hey, like I wanted to play around with this example request, I can load up exactly what was run for that prediction. Likewise, we can also view metrics over time. So I can see the peak requests per second, number of requests. So I can view a graph on the history of those requests coming in, as well as additional drift, which is don't have enough requests for that. But we can also look at our batch predictions. So we had set up the this demo Python model batch predictions. So in this case, our batch predictions are being written back to a feature group. We can also write directly to the console or to a storage or database connector. And so in this, we then have a batch prediction schedule that we had set up at the end of the notebook, which will then run this next time on February 28th at 12 a.m. And then we can also view this data. So we've got this batch prediction results, which is then written back to our feature group. So our batch prediction feature group is just treated as a input data set again. So we can view this as a feature group. So you can, if you view the materialized data, so I can see all the inputs, and then finally the prediction results. So this is the result returned by our model. Likewise, I can continue exploring, viewing different metrics on top of this. However, let's say that I didn't want to just look at a single distribution, but actually the distribution over all of the batch predictions that I've received over the life cycle of this, this deployment. So let's go ahead and look at the prediction metrics for batch predictions. So in that case, let's go to the drift. So you can see we have a distribution for the prediction data as well as the training data. So in this case, I use the exact same data for my input. But if I did use a different truncated data set for my batch predictions, I would see different distributions for all of the inputs between the prediction data and the training data. So this allows me to then see like, hey, like I've trained my data on a certain distribution, but now my predictions are definitely seeming to drift over time. I can actually understand what is the difference in terms of the data that I'm inputting. So it helps me understand better to know like what, how is my data changed over time. And so all of this is also available via the real-time API once we've received enough requests to have a some bucketing over the data drift. On top of that, let's say that I wanted to actually, let's say instead of making predictions, we also said that we would do a real-time feature store as part of this webinar. So let's go ahead and jump back to the projects. So we have another use case called the feature store. So this, rather than training a model, will instead allow us to use feature groups as our deployable object. So in this case, I preloaded three data sets, and movie attributes, user attributes, and then like the interactions between the two. This is using the IMDb training data set, which allows you to, or which was a historical data competition that allows you to take a bunch of users and a bunch of movies, and then score how each of those users rated movies in the library. So let's say in this case, we'll take a quick look at the data in here. So we have our user attributes. We'll pull open the raw data. And if you wanted to have some questions, but if you wanted to follow along with this, you can create or these are available via our personalized recommendations example data. So if you go create a new project and then look for our personalized recommendations use case, and then hit continue, give it a project name, and then you'll see a sample dataset button. So this will import these three data sets, which will be the user item interactions, the movie catalog, as well as the users. So I previously had done that here, in this one, and previously imported this data. So taking a quick look at this data, if we look at the movie attributes, this contains three columns, which is the movie ID, the movie name, and the genres. So taking a look at the raw data, I can see that movie ID is just an integer. We got the movie name and genres, which is a multi-categorical field. All right, so from here, let's say I wanted to deploy one of these feature groups to make this data available to me from an external service. And so I wanted to be able to very quickly query from my giant catalog of users or giant catalog of movies and find information or even interactions between a particular user and the movies that they've interacted with. So I can create this feature store use case. And then all that I need to do from here is then select one of my feature groups that I want to deploy. And we can, of course, attach existing feature groups from this screen. So if we go back to the main project dashboard, we can attach an existing feature group and select any of the feature groups we've previously created. I've already attached the sample data movie attributes and user attributes. So in this case, if I take a look at my movie attributes feature group, I then go to my features. I then need to say, hey, I want my movie ID to be indexable and available for me to query. So I select my movie ID feature as my record ID. And then finally, I hit deploy feature group, which will then create a new feature group for me to, or new deployment for me to then be able to query this data. So in order to not sit and spin to wait for that to come up, I've already pre-deployed both the users and the movies. So let's go ahead and take a look at one of these deployments. So I can go to the lookup API for one of these. So if I wanted to look up the user attributes for a particular user, I can look at the user deployment that I had created. And we have a example code here for you. You can also call this using curl. So we have both curl and Python examples. And then clicking on lookup features, I'll then be able to pull up in the user metadata for this user. Likewise, we can do the same thing for the movies. And so given movie ID number 1, I'll look up, and this should be Toy Story. So I got my movie ID, I got the movie and genres. Now, this is useful for looking up the catalog, but it would also be more interesting if we also added our user item interactions data set, and then could then look up all the interactions for a particular user on all the movies that they've interacted with. And so I can add additional filtering. So I can look up movies that they've recently looked at in the last, say, 10 days. And so we can have additional streaming data coming in here, which will then supply updated information to our feature store. So if I wanted to add an additional streaming, all I have to do is go to add data set. give it a new name. So this is going to be my user streaming data. It's going to give it a unique table name, streaming user data. And then rather than giving it a batch data set from a file upload or importing from one of our connectors, I can instead set up streaming. And then all I need to do is give it a record ID, which is going to be my user ID. And this is just going to tell the streaming interface to expect that I'm going to receive data which has an indexable ID along with every value there. So if I wanted to then test this, I can now upsert any amount of data using this sample code. And so let's go ahead and copy this and bring it back to our notebook. So if I add a new code block here, I can paste this. So we'll say insert a new user ID. So I'm going to give it a user ID 123. And then we can add any amount of data here. So I can, of course, add my name. We'll give this user's name Austin, and we'll give it gender. And so I will import this API client. We don't need to give it an API token, so we can now embed this specific API inside, say, a website or a backend as well. So all we need is a streaming token and the feature group ID. And then we'll send this data up, and then we should see that data immediately inside of here. So we're now receiving or set up a streaming ingester for our data. All right. And then finally, we can then join this data with our deployed user attributes. So from the feature group for the user attributes, so if I find my user attributes, I can merge streaming feature group. So I can select this user attributes. I'll join it on the streaming user data that I just created. And now this has been concatenated with that batch feature group. So I should then be able to utilize the streaming data as it comes in inside of my deployment next time that I deploy this feature group. Okay, so with that, we can check up on the status of our models. So let's go ahead and see what's going on there. So it appears that my model is done training. So we can see the output for our training function. So again, by calling, so jumping back over to where we were when things got caught up a little bit in the pipeline. So we were sitting and waiting for our models to finish training. So that appears to at least caught up for me. So we've got and then I got all the get training logs. So everything that I did in my model train function, whether I was using print functions or logging, I can view the logging info that I created in here. So all of this is now output via logging info. And then if my model had crashed, I would have seen the stack trace as well in the standard error section here, as well as any exceptions. So the exceptions would also have appeared in different keyword variable here. Then finally, I did override my API client. So it does not have an API key, so I got an access denied when trying to create the deployment. So let me go ahead and reinitialize that client with my API key. And so now I can go ahead and create my deployment. And so let's see, create deployment model ID, that should be good. Now all I'll need to do is wait for that deployment to spin up. So in order to see all of this inside of the UI, so we have the ability to view the logs inside of the project as well. So if I went back to my demo Python model, we can see the model version, each model version. So every time that I retrain my model, I'll have unique logs for this. So loading this up, I can see the exact same logs without the color formatting. And this would also have any stack traces. If my model was crashed, if I had a typo, this would also appear here. And so let's say that I went and wanted to go in and update this, and let's just raise a new exception right here at the beginning. So I'll raise an exception right there in the train function and hit save. And then I can take this and retrain using the latest code. So this should hopefully crash really quick, and then we'll be able to view the stack trace of those logs. And then from this, and then from here, if I did have, and then I went and updated the function code and redeploy and wanted to deploy my new code, I could deploy create a new deployment or go to my deployment page. And then from your deployment, you can actually select which model version you want to deploy. So it'll show you a list of available model versions. This will just say, hey, like this one's pending. But if there are any failed model versions, it won't allow you to deploy it because you can only deploy successfully trained models. All right, so let's see, looking at some of the questions here while this is going. So some of the questions were around the lag, and if downloading the code would have made it faster. So all of the lag was just in terms of the number of pipelines available for free trials. So there is a limited pool on that, and so we did have a little bit of a backlog in terms of the number of people training. So those should have caught up at this point. If you are still hitting timeout errors, so we are, it appears like I'm also in line for getting a deployment. So there is a little bit of a wait there. So you will still likely hit that wait time of 480 seconds. You're still in line. So you can increase your timeout. Otherwise, come back and revisit it in just a few minutes. And if you go through the UI as well, you should be able to see your deployments and their current status as well.
You can just rerun that cell.
Yeah, you can set and rerun the cell after you've hit the timeout.
It is catching up. It is a number of pods that came at the same time. I think one question that came in that question that came up is the speed of training with respect to training locally. For simple functions, for data that like fits in memory, of course, it's quick to train locally. The thing to emphasize here is it's not just that training one time or training locally for like the initial testing. It's the registering it in the platform so that it can be rerun nightly, once every hour as new data arrives. So it's not just a speed of training thing. Most of it is about automating or making the workflow sort of robust and automated on the platform, more than like the specific speed of training, like one execution of the function.
It's also good to note that in the Abacus platform, you can also request the amount of memory or the CPU size. So you're going to get a lot more resources available to you than what's available in Colab, which is usually pretty light in terms of the RAM and disk and CPU that's available, as this is a free service from Google that's available quickly. I think runs in the back as like spot instances, so it's very quick to be evicted or lose progress. And so yeah, you can run much larger jobs inside of Abacus with large amounts of data. Let's see. And so I think, okay, so we did finally get the error from our training job. So it seems like that queue is emptying out. So we got our error hello world. If we view the logs, we should now see our stack trace. So line 5 of train function, we had the exception. Here's the exception message. So that's a quick flyover of how you can debug your model training inside of Abacus. And so hopefully most of you should have gotten your deployment by now. I should be in the back of the queue since I just created mine. But once that deployment is live, you should be able to make real-time predictions on your deployments, be able to see that it's exactly what was trained locally and get the same results. If we did switch back to sorry, if we did, and you should see the metrics for your batch predictions, or for both your real-time predictions as well as your batch predictions. And then I did go through some examples of how to create a feature store using the product. Now, just to go over a couple more items in terms of what's available. So inside, as mentioned, we have a lot of use cases available for you inside of the Abacus platform that allows you to do deep learning and auto ML. So we have personalization and recommendations, forecasting, which allows you to predict a certain number of time steps into the future. Our predictive modeling handles generic classification or regression. We have a vision use case, as well as some NLP tools. And then we also have predictive lead scoring, which is a bit more applied, and also anomaly detection, which is a bit more applied classification. And then again, the fraud security. And then we have additional model drift and monitoring, a feature store, and plug and play, which contains all of the ML ops related things that we've talked about today, as well as some vector matching engines. We have our Dockerized model, so you can upload your Dockerized model and we'll be able to host that directly inside of Abacus. And then the custom Python model is what we were mostly focusing on today.
In a couple of the answers, I've referred to like templated use cases, and a templated use case would be something like a customer churn prediction problem, where customer churn problems tend to have a particular way the data comes as a user account. There's some kind of monthly subscription history. You're trying to predict whether the customer is going to renew their subscription at some future point. Like it might be 3 months ahead, it might be 1 year ahead. And so, we have this templated setup where you can specify the user table, the monthly subscription table, join them appropriately, set the targets, and then we have deep learning models and it's not just deep learning. We also train gradient boosted trees and other models that are optimized for that use case, for predicting on that kind of structure, and give you results that you can evaluate in terms of how effectively you're able to predict whether a customer will renew or drop out, and those kind of things. So that's roughly what we were referring to as like templated use cases. And that's where it's very different from like a raw platform where you have tools and you have models and you're responsible for like everything from like manipulating the data to like shaping how the data will come into the model, deciding what kind of model to use or how to construct model search, how to evaluate those models over the different things, constructing train test splits for all of these different things like forecasting and so on. We have automatic code to like decide how to split your data so that you have realistic validation results. So in forecasting, we pay a lot of attention to causality when generating splits, so that the time periods are separated or separated by items and so on. So that's some of the features that come when you're using Abacus for model training and model construction.
And likewise, when you're not using your own Python modeling, we also provide a lot of additional metrics during model training. And so you can actually see your use case or problem type specific metrics on the model, which you can then compare different approaches if you had additional advanced model details. So if you train a new model and you're trying different data or you use a different test split, we have a lot of advanced features available, which are inputs for the model training. And these are all specific to each of the available problem types inside of the platform. And then it allows you to directly then compare the model performance across different training runs. And so this would allow you to better visualize your metrics, which again is not quite available when you're using your own Python model, as you would need to be able to run metrics on your own code. But this would then be some of the tooling available to you using our end-to-end platform. So a couple more questions. There is a certificate that we will send to you after the course. So you'll get that in your email. Let's see. Siddhartha, did you want to answer the vector matching engine question?
Answer in typing will be easier to answer live. It's definitely easier in typing. So vector matching is what is used for essentially recommendations when you're computing embeddings for like a catalog. So you have this high dimensional, like maybe a 64 dimensional, 128 dimensional representation of items in your catalog, and then you have a model that generates a similar embedding for a user, and the recommendation you make is by the users who are closest to whichever item catalogs are closest to the user's vector in terms of dot product or cosine or cosine distance metrics. And so we have an engine that allows you to do that at low latency at scale for like catalogs running into like the many millions of items, so that you can if you have a custom model that generates these embeddings for your catalog and user, but you don't have the code to serve that sort of matching engine in real time, we can support that matching engine for you. So that's the vector matching use cases. So we for it's a fairly common pattern for people doing recommendations using deep learning currently. Yeah, I think someone else, yes, cosine similarity. We support like, the standard distance metrics like dot product, cosine, Manhattan distance. Yeah, I think there's still some questions about like comparisons between like Azure ML Ops and like AWS SageMaker that has components that are related to ML Ops. I think one thing that will become a little apparent from like the way the dashboard got constructed and so on was that the product is very it's constructed so that like ML ops is built into the model training process. Like as you create models, we're already creating pipelines. Maybe Austin, you want to just show a refresh schedule, like where like a refresh schedule hangs off it. So you train a model, you immediately have a place to like automate it so that it can run at a regular cadence. You saw those metrics and monitoring dashboards. You have a model, you're generating batch predictions. You immediately get monitoring for your model so that you can start looking at like what's happening to your input features, what's happening to your predictions. Austin showed you an example of a failure during training that automatically will send emails to the person who initiated the training, or that as however you configured your alerting to work, so that you can get notified of like failures in this scheduled training. You can the other thing that's like that is important to emphasize. So maybe Austin, if you go to a feature group, so you can compute, you can construct complex feature dependencies, like basically one feature defined in terms of other features, joins, all of that. And then you can have data sets that are all updating on different refresh schedules. And the platform takes care of like recomputing what is necessary to train the new model to generate a new set of batch predictions. So it'll go through and pull like the latest versions of data sets, recompute what's necessary, redo those joins using the code that you have registered, and then run the prediction. So all of this kind of comes very naturally without having to like orchestrate or use like individual components of like an ML ops platform to build this yourself. Sorry, I was talking a bit quickly, but yeah, Austin showing.
So again, just you're able to then do, so let's say I had my concrete data. I can also join additional data. So if I wanted to somehow contrive an example for joining on the user data using some sort of model ID equals, sorry, user ID equals some sort of concrete ID. So you can do advanced joins and do additional information here in the create new columns using concatenating different data together. And so this would allow you to do some advanced features on top of your existing data, and then rematerialize on a schedule, export it, or rerun through model training.
People asking questions about other aspects of platform too. I think one thing, since we're coming up, I will mention that the platform has a fairly large set of features, and we do different workshops focused on different parts. We will definitely be looking at I think there are workshops coming up on the model monitoring aspect of it, some of the other more advanced sort of even Python code by calling into one API from the Python code so that you can chain models together and so on. So we'll cover those in future workshops. So just keep an eye out. I don't think we'll get to everything that was been asked in this workshop, but we try our best. But we will follow up with future workshops that cover some of these in more detail. Looks like some people are completing their notebooks completely also.
Yeah, excellent. I don't see any additional questions. We might be able to wrap this up 6 minutes early. And so, yeah, thank you everyone for joining us today, and bearing with us with the large number of people that joined in and scheduled pipeline jobs. So we appreciate it.
Thank you, everyone. Hopefully it was informative, and you had a lot of great questions. It was fun to see all the questions coming through.
Record.